Welcome back to Statistical Reasoning. We are starting Chapter 9 in Elementary Statistics. Chapter 9 starts working with two samples, whether with a proportion or a mean, instead of just working with one group. So we're going to run a test or make a confidence interval when we are trying to compare two population proportions to each other. So with our symbols, we want to make sure we get our notation right. So we still have P for the population proportion. Now this example is using a number 1 to differentiate between the first proportion. You also could use letters that designate what you're talking about if that's easier for you. P hat is the sample proportion, N is the size of the first sample. We still have the complement, which is Q hat. And we still have X, which is the thing we're focusing on, and of course you would have all those exact same notations for the second group. We have requirements that we would need to fulfill just like any other test. This time we have to make sure both of the samples have are simple random. We have to make sure both of them are independent, that one answer is not being affected by another answer. And just like before, we need to make sure that in each group we have 5 successes and at least 5 failures in each of the two samples. I'm going to focus on the p-value method instead of the critical value method. So when we write our actual hypothesis this time, we're going to compare the two populations, so our null will be that P1 is equal to P2. And then for our hypothesis, for our alternative, we have our options. So it could be P1 is less than P2. It could be P1 is greater than P2. Or it could be that P1 is equal to P2. So those are the 3 different options. And I was talking earlier about you could write it a little bit differently. So like we're going to do an example with New York and California. So you could do the proportion for New York and the proportion for California. And they could either be greater than, less than, or so on. So you can use 1s and 2s, or you can use letters that designate the exact groups that you're talking about. So the example we're going to talk about is license plates in both New York and Connecticut. So they both have laws that require front and rear license plates. Idaho requires both, but Washington doesn't. It only requires one. So we have similar situations out here. So the proportion of illegal cars with rear license plates only in Connecticut is 239 out of 2,049. Proportion of New York illegal cars with rear license plates only is 9 out of 550. The sample percentages are 11.7 and 1.6. They definitely look different, but we need to find out if they are significantly different. So here's the information just sitting in a table versus sitting in a paragraph. We still are going to use an alpha level of 0.05, and we're going to focus on the p-value method. Our claim is that Connecticut and New York have the same proportion of cars with rear license plates only. So we're going to focus on our alternative being that they're equal, or our claim being that they're equal. So first we have to check our requirements. So the two samples, as far as we know, are simple random samples. They are independent because what one car does is not going to affect another car. The only way they would be affected is if they were owned by the same person, and since they were simply random sampled, they probably are not. And then if we check our amount of successes for the groups and our failures, the number of successes for Connecticut was 239. The number of failures was 1810, so those are both greater than 5. New York had 9 successes and 541 failures, so again, we're both bigger than 5. So when we go to write our claim, and I tend to write things like the N's and the C's because I think it's easier to keep track of what's what. If you do P1, then somewhere you need to note that P1 is New York. And if you do P2, you need to note somewhere that that 2 is Connecticut. This way I don't have to do that. So our claim is that both are equal. So that's our null. Since we don't care about if one's greater than the other one, we just want to know if they're equal or not. Our alternative is P1 is not equal to Pn. Pn is not equal to Pc. New York and Connecticut are not equal. Our alpha level was 0.05, so I run a 2-prop z-test. So I run a 2-prop z-test. I put in the information. I come out with a z-score of 7.11, which is quite large. Therefore, I have a p-value that's small, 0.0002. Since my p-value is definitely less than my alpha level, I am going to reject the null. So then I look at my chart to help me write this if I can't do it by hand, do it without the chart. There is sufficient evidence to conclude that Connecticut and New York have different proportions of cars with rear license plates only. Now, notice we were just doing that they're not equal, so I can't say who's bigger than the other one. I just know that they're not the same. Now, if I wanted to find a confidence interval about this claim, I would just do a 2-prop interval. And so when I run it and put in my information, I come up with this. For my confidence interval, 0.0828 is less than P1 minus P2, which is less than 0.118. Notice 0 is not in this claim. Since 0 is not in this claim, I definitely could say that one group is bigger than the other group. I just don't know which one because haven't looked into which one did I put in. I just know that they definitely are different. If for some reason the samples aren't satisfied, so for instance if you had bad samples, there's nothing you can do with that, just don't run your test. You need to fix your sampling procedures and start over. If we violate the fact that they have not enough successes or failures, there is an option called the Fisher's exact test, and we're not going to learn this in this class. If you go on in statistics, then you'll learn that. There's also a thing called bootstrapping, which you could do, and again, we're not going to learn that. We're just staying with the basics of statistics, but there are options when you violate one of the rules, then there are different tests you have to run. So next video we'll talk about means, and I will be posting that as soon as I can. Have a good day.